Good morning. It's February 24th and this is your daily brief in science. Here's everything you need to know. A uterine transplant milestone is under the spotlight as UK teams announce 5 womb transplants through Womb Transplant UK, including 2 from living donors and 3 from deceased donors, with 2 babies born from the deceased donor procedures. Deceased donor womb donation operates separately from standard organ donation and requires explicit family consent, with families approached specifically about womb donation. The program's pregnancies, including Hugo, rely on donor family consent and a highly collaborative team effort to support each pregnancy. A consultant obstetrician and a team of more than 30 expert staff monitored and delivered the baby, illustrating the scale of coordination behind womb transplant pregnancies. Key figures include team leads, Professor Richard Smith, Miss Isabel Quiroga, and obstetrician Bryony Jones, while donor families describe grief tempered by the life-saving gift. Grace Bell, diagnosed with MRKH in adolescence, received a womb transplant in 2024 at the Oxford Transplant Centre after fertility treatment, enabling the possibility of conception. Bell, unable to carry a pregnancy due to MRKH, learned early she would not bear her own child and later had a donor womb transplanted, enabling her to conceive. Bell's transplant was followed by IVF and embryo procedures at a London clinic, marking a notable case within Europe for deceased donor womb transplants. Both mothers, Grace Powell and Grace Davidson, have MRKH syndrome with functioning ovaries, which supports fertility treatment alongside womb transplantation. Hugo's birth and an earlier living donor case show that MRKH women can pursue fertilization and birth via womb transplantation. Medical teams stress honesty about the relatively limited global experience with uterine transplants, while leveraging transferable skills from other organ transplants to manage pregnancies. Hugo's birth demonstrates that girls and young women without a womb can carry their own child, though the donor has no genetic link to the baby. 2 separate mechanisms underlie the horse's whinny, a discovery that could change how we understand equine communication. Researchers published in Current Biology report a low-pitched component produced by air vibrating in the vocal folds, and a high-pitched whistling component that originates in the voice box and escapes through a small opening above it. Endoscopy allowed visualization of the laryngeal movements, including the cartilage above the vocal folds contracting during the call. Ex vivo experiments replicated the sound, supporting a 2-source mechanism for the same vocalization. The study was led by Elodie Mandel-Briefer and colleagues. Outside experts from the University of Connecticut, Rutgers, and the University of Copenhagen called the finding novel and potentially significant for understanding how horses communicate. Briefer notes the dual-frequency whinny could convey multiple messages at once, expanding the range of emotions expressed during social interactions. The research team observed a low-pitched component tied to the vocal folds and a separate high-pitched component arising from the voice box. The high-frequency part escapes through a small opening, adding a second channel to the call. This suggests horses might encode more information in a single vocalization than previously recognized. The findings open questions about how other horse vocalizations might combine multiple sound sources. A cancer therapy approach with a twist. Anixa Biosciences is advancing Lyricel, a CRT CAR-T treatment developed with Moffitt Cancer Center, alongside a portfolio of vaccines from Cleveland Clinic origin licensed to Anixa with revenue terms spelled out in collaboration deals. Lyricel uses CERT technology, engaging the FSH receptor with the natural ligand FSH rather than an antibody, and its development includes collaboration with Duke-associated researchers led by Dr. Jose Conejo Garcia. Cleveland Clinic-originated vaccines for breast and ovarian cancer are part of Anixa's portfolio and are licensed under revenue-sharing terms outlined in their partnerships. The press release includes standard forward-looking statements and risk disclosures, noting results may differ from expectations, and that updates beyond legal requirements are not promised. Investors are told not to treat these forward-looking statements as guaranteed future performance. Media inquiries are directed to Mike Catalani with his contact details provided. The release notes market context, mentioning recent ANIX trading patterns and a tendency for negative moves after positive clinical or IP updates, framed as rising scientific visibility for Anixa. Dr. Conejo Garcia, a Duke immunology professor and co-inventor of the FSHR-mediated CAR-T technology, will keynote the SCTR 2026 retreat on March 6, 2026. His talk will emphasize the FSHR-mediated CAR-T work underpinning lira-cel and its progress through ANIXA's program. The keynote will cover the ongoing Phase 1 trial of liraglutide autoleucel, or lira-cel, targeting FSHR in recurrent ovarian cancer, enrolling adult women after 2 or more prior therapies. Lira-cel targets FSHR expressed on ovarian cancer cells, tumor vasculature, and some healthy ovarian cells, while aiming to spare healthy tissue. Dr. Conejo Garcia's presentation will detail the discovery of the FSHR-mediated CAR-T approach and its advancement through the lira-cel program. Mental health care is moving to the forefront of cancer treatment, with routine early screening and tailored support now part of standard practice. A UC Health System study shows that addressing psychosocial needs can influence outcomes and quality of life for cancer patients. Lead author Dr. Julian Hong of UCSF says, the findings replicate prior UC system results and reinforce a link between mental health management and cancer mortality. The research uses electronic health records from a large, diverse UC cohort and controls for confounders to support a potential causal interpretation. Anxiety and depression were the most commonly diagnosed early mental health disorders among patients in the study. Developing a mental health disorder within a year of cancer diagnosis is associated with a 51% higher risk of death in the first 1 to 3 years, then a 17% higher risk from 3 to 5 years, becoming non-significant after 5 years. Across UC-affiliated hospitals, about 10.6% of cancer patients without prior mental health disorders developed a mental health condition within the first year of diagnosis. The UC-wide study links early-onset mental health disorders post-diagnosis to higher short-term mortality in cancer patients. Findings are published in Cancer 2026, based on data from the UC Health System covering cancer patients diagnosed from 2013 to 2023. Possible mechanisms discussed include stress-related hormonal changes that may influence tumor biology, pointing to biomedical research avenues on the mental health cancer axis. A new step in gene editing promises greater precision with a single letter change in DNA. A joint team from the University of Pennsylvania and Rice University reports a refined base pair editor that swaps one DNA letter with far fewer unintended edits, aiming to improve safety for potential genetic therapies, including cystic fibrosis. The researchers describe achieving a precision closer to editing a single document letter, hoping to limit changes to the targeted position without touching neighboring letters. Funding came from the NIH, NSF, and the Cystic Fibrosis Foundation, with the authors noting the data reflect their findings and not necessarily the funders' views. The work was conducted at Penn Engineering and Rice University and was published in Molecular Therapy in mid-January 2026. The team emphasizes that the technology enables accurate modeling of disease mutations in lab cells, informing drug testing and patient-specific strategies. In cystic fibrosis models, they introduced and corrected CF-related mutations in human epithelial cells, showing both editing and reversal of these mutations with improved cellular function. The findings suggest potential for long-lasting or permanent treatments, offering benefits over some current therapies by enabling precise single-letter edits. In human cell tests, the most accurate editor reduced bystander edits by more than 80% while maintaining high activity at the target site, addressing a major safety concern. The work remains preclinical but shows substantial reductions in unintended edits at CF-related sites, indicating potential for long-lasting therapies pending further development. Beyond CF, the refined editor broadens the toolkit for precisely modeling and correcting single-letter mutations, supporting more personalized medicine approaches. The technical advance comes from shortening and stiffening the DNA targeting linker and adjusting the editor's interaction with DNA, tightening the leash to prevent off-target edits. While therapies like Trikafta help CF patients, this precise base editing could offer durable solutions if off-target risks are minimized and long-term benefits are realized. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.